Okay, section 1.4, solving absolute value equations. Absolute value is the distance from 0 on the number line. That's supposed to be a line there. So, if we were in class, and maybe I'll try to show this anyway, it doesn't matter if let's say this is Billy Bob, because you know, we put BB for Billy Bob, and here I am, I'm 6 foot away. If I stand over here, like this is aerial view, I'm still about 6 foot away. I'm about 6 foot away from Billy Bob if I stand over here. I'm, of course, off the screen, but about 6 foot away. I can never be a negative distance from Billy Bob. Now, some of you might say, well, if I dig a hole in the ground, well, if I dig a hole in the ground, I'm still about 6 feet away from Billy Bob. And if I stand on the ceiling, if that were a possibility, I'd be about 6 feet away from Billy Bob. I am never negative 6 feet away from Billy Bob. So absolute value is the distance from 0 on a number line because distance is always going to be positive. So here's your 6 units this way. Even at negative 6, if you're standing right here, you are still 6 units away from 0. And how do we represent that with our math? We write the goalposts. That's what I always think of those as, goalposts, to represent the absolute value. Okay, a book definition right there for any real number A. If A is positive or 0, the absolute value of A is A. Meaning, okay, what does that mean for you? Here's the absolute value of 4. Well, it comes out just to be 4. Okay? The absolute value, if A is negative, like right here we have a negative 2, then the absolute value of A is the opposite of A. And most of you know the absolute value of negative 2 comes out to be 2. The distance of negative 2 away from 0 on a number line is 2 units away, hence the 2. All right? And of course 0 is just going to be 0. Here we go, example 1. When evaluating, so we're just evaluating this one, we're not solving. Absolute value bars act as grouping symbols. Perform any operations inside the absolute values first. Okay, so it's just like order of operations. You just have to remember, kind of like with fractions, you think of the numerator and the denominator as having, as a group, as a parentheses. You kind of have like an imaginary parenthesis going on right here. Not very well drawn, but you get the idea. So this is actually 2.7 plus the absolute value of 6 minus 2 times x, which is the value of 4. And then we go on from here. So inside this parenthesis, I mean absolute value, hence we're going to think parenthesis kind of, I have a multiplication which I have to do first. So 2.7 plus absolute value of 6 minus 8. All right, now I do this piece. I've got to do what's in the absolute value next. So I have 2.7 plus the absolute value of negative 2, which gives me 2.7 plus 2. The absolute value of negative 2 is just a plain old 2. And 2 plus 2.7 is 4.7. Okay, moving along. Example 2, kind of the same type of problem. 2.3 minus absolute value of 3 times y. Notice how when I substitute in, I put it in parentheses, and that also means multiplication. All right, now we have 2.3 minus the absolute value of 6 minus 10, absolute value. So 2.3 minus 6 minus 10 is negative 4. 2 minus 3, notice how this minus sign stays here. The absolute value of negative 4 is just a plain old 4. And then I just take 2.3 minus 4, which is going to give me a negative 1.7. All right, example 3. Oh, this isn't example 3 yet. I have some explaining to do. For any real numbers A and B where B is greater than or equal to 0, if the absolute value of A equals B, then A equals B or negative A equals B. The second case oftentimes is written as A equals negative B. Okay, meaning they just divided both sides by negative 1, and you get this A equals negative B thing. Okay, what does that mean for us? And this is, you know, in class I might use an envelope. If I don't remember, please remind me and I can kind of quick show you how I want to do this. But what number could go in place of x here? And most of you guys, you know 12. Well, the absolute value of 12 is 12. So you're like, yay, I got it, Mrs. Talley. But here's the kicker with this. Kicker, because I think of these as goalposts. Yeah. What else could go in there? Oh, yeah. Absolute value of negative 12 could also be 12. So when you write out your solutions here, you can either write 12 and negative 12, or one of my favorite mathematical things to do is write plus or minus 12. Your answer could be plus 12 or it could be minus 12. All right, now think about that right here. Doesn't that mean this inside the absolute value could be 12 or negative 12? Yes, it does. The thing about this is now you can't just write out 12 and negative 12. You have to write out x minus 4 could be 12. In other words, this, oh, I wish I could put my hand, this, maybe I need a box. Let me put a box quick to maybe help a little bit with the explanation. No, it's got to be filled in. Hold on, sorry for the little delay here. We're going to get this straightened out, okay? This box could be 12 or it could be negative 12, okay? But what's in the box? X minus 4. So I have to write out x minus 4 equals 12, and yes, you have to write out x minus 4 equals negative 12. Then you have to solve both of these, okay? If I add 4 to both sides, I get 16. And over here, if I add 4 to both sides, I don't get negative 16. That's the thing. Everybody, oh, it's 16 and negative 16. No, it doesn't work out that way. You wish, but it just doesn't. And some of you are stubborn and you're just going to write down 16 and negative 16 anyway. Don't do it because it will be wrong. Okay, your answers are 16 and negative 8. Let's try it out. What is 16 minus 4? 12. What's the absolute value of 12? 12. So we know this one works. Negative 8. Negative 8 minus 4 is negative 12. Absolute value of negative 12 is 12. So that works as well. All right, and then you have to do the same thing here. You would have 8x minus 4 equals 12, and then you have to write out 8x minus 4 equals negative 12. All right, that means 8x equals 16. That means x equals 2. So one of your solutions. All right, over here I got 8x. I'm going to add 4 to both sides. So that gives me an 8. Divide both sides by 8. I didn't actually show you what I was doing over there. I just kind of did, and I'm kind of hoping you are to that level. All right, I got 1 and I've got a 2. Uh-oh. I added 4, I get negative 8. This should be a negative 1. Let me go ahead and check. 2 times 8 is 16. 16 minus 4 is 12. The absolute value of 12 is 12. Okay? Put in negative 1. Now I have negative 8 minus 4 is negative 12. The absolute value of negative 12 is 12. All right, let's keep rocking your world a little bit here. Example 3. Same idea. You're going to have to write out y plus 3 equals 8. And you're going to have to write out y plus 3 equals negative 8. Because this inside, it could be absolute value of 8 equals 8, or it could be absolute value of negative 8 equals 8. So basically at this point, I'm setting this equal to this, and I'm setting this, this right here equal to the 8 as well. Subtract 3 from both sides, I get a 5. And if I subtract 3 from both sides over here, I get negative 11. Example 4. Oh, did I go back and check my answer? I want to keep checking my answer because, like I said, I'm not good at that. 5 plus 3 is 8. Absolute value of 8 is 8. Negative 11. Negative 11 plus 3 is negative 8. The absolute value of negative 8 is 8. So I believe this one is good to go. All right, here we go again. What's the solution? I have to say either this inside could be 15 or it could be negative 15. So I set 2x plus 5 equal to 15. I set 2x plus 5 equal to negative 15. Solve away. Subtract 5 from both sides, and then I divide by 2. I get a 5. Over here I subtract 5. That gives me a negative 20. Now I divide both sides by 2. If you need help explaining these steps, you're going to have to jump in before after school, because that means you need a whole other level of solving equation help. All right, let's just double check, make sure it works right. 5. 5 times 2 is 10. 10 plus 5 is 15. The absolute value of 15 is 15. Woohoo! Then we do negative 10. Negative 10 times 2 is negative 20. Negative 20 plus 5 is negative 15, which is what I wanted. Absolute value of negative 15 is 15. Woohoo! All right. Example 5. Okay, now I have this, and I have got to get the absolute value alone. Okay, I have kids who sometimes forget that this is a good example because you're like, what am I setting it equal to? So 6 minus 4t, the absolute value, is equal to, here's where I'm going to subtract 5 from both sides because it's not in the absolute value, so I have it equal to negative 5. Okay, it's very easy, and this is one of those things on the quiz or the test. You're going to be like, ah! Yeah, that sound exactly. Look at this. We have an absolute value, and I don't care what number it is, equal to a negative 5. That means you're saying your distance from 0 on a number line is negative 5. Is that even possible? No, as we discussed at the beginning of the lesson, you cannot ever stand negative 5 feet away or ever be a negative 5 distance from anything. So basically, this is going to be unsolvable, and we'll see. Do you remember what you're going to do when it's not possible to be solved? Because, and here's a nice little explanation, because the absolute value of a number is always positive or 0, the equation above is never true. Thus, it has no solution. The solution set for this type of equation is what we call empty set. I know once you start writing it, you're like, oh, I love it, empty set. That's how we write it. Or fancy, like proper. Here's a set and it's empty. Either one will work. Okay, I would prefer that you do that rather than writing no solution. I actually like this symbol a lot. Okay, example 6. Okay, this one is kind of a doozy. Look at this. This could either be positive or this could be negative. So I go ahead and I'm going to say 8 plus y could be equal to 2y minus 3, or 8 plus y could be equal to negative. Notice what I'm doing, I put negative in front of the whole thing. Some of you will be able to skip the first step because you're going to be on the ball enough to say, hey, I can change this to negative, then I also have to change, I shouldn't say negative, the opposite sign to the opposite sign. Okay, let's go ahead and solve this one right here. I want my y's on the same side of the equation. It just depends on what you'd like to do. I'm going to do this, subtract 2y from both sides. So I have 8 minus y equals negative 3. Now I'm going to subtract 8 from both sides. There's another way to do this. I'm actually not going to show you the other way. Probably some of you will do it automatically. Y equals 11. Let me check that right now before I forget. 11 plus 8 is 19. Okay? I have 11 times 2, which is 22, and then minus 3 is 19. So I know this one works. And you're thinking, Mrs. Talley, you don't have to show me every time. Yes, I do, because here it goes. 8 plus y equals, distribute the negative to each piece. All right, so basically it ends up being the opposite sign as I started with. So some of you could possibly go on to this step, but you need to be really on your toes. Otherwise, you're going to forget. All right, now I'm going to put my y's on the same side. So I'm going to add 2y to both sides of the equation. This cancels out. I have 8 plus 3y equals 3. Now I'm going to get y by itself, so I subtract 8. That 3y is joined with this, and now I have a negative 5. And then I go ahead and I have y equals negative 5/3. Okay, now negative 5/3 plus 8. Let me think in terms of it's 1 2/3, so 7, 6 1/3. Okay, I put 5/3. It's actually negative 5/3. Okay, and you might use the calculator, but negative 10/3 is what that is, because I have top times the top, bottom times the bottom, minus 3, which is actually 9/3, because 9 over 3 is 3, so I have negative 19/3. That's the same as negative 6 1/3. Okay, and you're like, oh, there's going to be a quick little mistake in there. There is not. Is 6 1/3 equal to negative 6 1/3? No. So what I'm saying is this one does not work. And let's see what this little box down here says. It is important to check your answers, which I know I'm horrible at it, but when solving absolute value equations, even the correct procedure for solving, even if the correct procedure is used, the answer may not actually be an actual solution to the original equation. Okay, and this, you may have had this before. We call them extraneous solutions. I think that's with 2 N's. Extraneous solution. So this is why it is so super duper important to check. This looks like it's going to work. It seemed like even the same number came out, but this one's positive, this one's negative. It does not work. So sometimes in absolute value equations, we're going to get these 2 answers, and one of them will not work. It's just like a cruel math joke to play on you. All right? I'm going to have you try to do as much of example 7 as possible. I'm going to get you started. Okay, 3x minus 5 is equal to 2x plus 1. And then you're going to have to solve 3x minus 5 is equal to, here's the kicker, a negative of that quantity. Some of you may, as you practice this more and more, may feel confident doing this. All right, so you need to solve each one of those, and you need to check your answer to see if it works, because you might, or you might not, have an extraneous solution, and that's what's frustrating about that. All right, and this ends our lesson.